Okay, Unit 6, Day 2a, we're going to talk about dot products of vectors. Now, when you're talking about vectors, there's actually two ways. There's going to be two ways to multiply vectors. One way we're going to do in this class or in this unit, and one we're not going to do. So, now a cross product, you might hear this, and I guess I want to mention it. That way, if you start Googling for help and you come across cross product, it's not the same thing as a dot product. So there's a cross product and there's a dot product. The cross product results in a vector. So that's the key. When you're done with it, you have a new vector. So it's a vector that is perpendicular. Let's put this. It's perpendicular to both of the vectors. So it's going to be a third vector that's perpendicular to the first two. Or at least it's going to be perpendicular to the plane that those first two are in. It has to do with 3 dimensions, and that's beyond what we need to do in this unit. The dot product then is going to result in a scalar. Which is it's going to be a number, and those numbers mean something, and we can use them for a lot of cool things. So dot product, or inner product's another name for it. We can call it inner product or dot product. Is if I'm going to take, let U be U1, U2, and V be the vector V1, V2, then U dot V, and it looks like multiplication, it's the multiplication dot, it's going to be U1 times V1 plus U2 times V2, which, like I said, is going to equal a number now. So when you're done, you add them together to get a number. Another thing we're going to use here, another formula, this guy right here, if you want to find the angle between two vectors, the dot product actually helps us do that. So if I want to find theta, so I'll say let theta be the angle between two vectors, then this is true. The dot product is going to equal the magnitude of u times the magnitude of v times the cosine of theta. So if I really just want to find that theta, let's get theta by itself. So I would divide the magnitudes over. So it would be u dot v divided by the magnitude of u times the magnitude of v. That would equal cosine. And then if I took the inverse cosine of this, so theta would be the inverse cosine of that. So if you want to find the angle between two vectors, plug it in here. We don't have to do, use a calculator for any crazy other things or draw a picture. It's just type it into here. We use a calculator for this, but it's a whole lot easier. So just some other properties here, and I did find a typo in this, so I want to point that out right away. This one right here should be a u. So if you have u dot v, sorry, my video froze. U dot v would be the same thing as v dot u. The order does not matter. If you were to take u dot u, that's the same thing as the magnitude squared. So you could save your time and just do the magnitude squared. If you had 0, if you did the dot product with 0 and u, the answer is going to be 0. 0 being the 0 vector or the origin, you would get 0 for an answer. If you were going to be adding v plus w, getting the resultant, and then doing a dot product of u with that resultant, you could do u with v, u dot v, and u dot w, and then add them together. Same idea here, just switch the order. So instead of having that second, now it's first. If you had c, where c is a scalar, and let's see, I could even say this too. So if you're on c times the dot product, but you don't want to distribute it. You only want to take it times one of them. So I could take c times v and then do the dot product with u, or I could take c times u and do a dot product with v, but do not distribute with that. Okay, so when you're doing the dot product, you don't want to distribute the c out. Don't do that. Okay, 9 times out of 10 in math, distribution is good, but with dot product it is not. Okay, so let's do some dot products here. So I'm going to give you some vectors in different forms. I'm going to ask you to find the dot products. So on this one, if u is 3, 9 and v is 6, 5, then u dot v would equal 3 times 6 plus 9 times 5. So that'd be 18 plus 45, which is 63. Notice the answer is just a number. Okay, and that number is important. We can use that number for a lot of things, but it's not a new vector. It's just a number. this one here, going to u dot v, and we're going to multiply the x components together, so this would be -1 times -6, plus, and then 5 times -2. So this would be 6 plus -10, which is -4. So I got -4 from my dot product. Here, 8, 4, and -7, -9. Well, the dot product would be 8 times -7. Oops, I'll put it in parentheses here. Plus 4 times -9. So -56 plus -36 would be a -92. Okay, and then this guy here, these are the magnitudes, and this is the angle. So with my calculator, because eventually when I need to use my calculator, I'm going to put it in radian mode right off the bat so I can use radians. But if u dot v means to add the x components together, I'm going to do this. I'm going to say one x component would be the magnitude of u cosine 2 pi over 3, and then the times, and the other x component would be the net magnitude of v times the cosine of 2 pi over 3. Add to that the y component of the first one would be 4 sine 2 pi over 3 times 10 sine 2 pi over 3. So you could actually type that all in the calculator at once if you want. And if you type this in, you get 10. If you type this in, you get 30. So it is 40 in the end would be the dot product of that. Okay, now let's go to the back side. And you kind of got options here. So I would really like for you to pick a different picture than I do. It says to draw two vectors that are perpendicular to each other. Okay, so they have to be perpendicular in some way. You can do straight up and down, left and right. If you do it this way, if you did this one has a slope of 1, that's a slope of -1, because those are perpendicular. Just remember, opposite reciprocals for slope would be perpendicular. So pick anything, and I'll just put a point over here. So this would be this vector right here. 1, 2, 3, 4, 1, 2, 3. So this is 4, 3. So the slope would be up 3, right 4. So I'm just thinking slope is up 3, right 4. So now I need to find a slope that is down 4, right 3. So I think I'm going to go down 4, 1, 2, 3, 4, right 3, 1, 2, 3. And those I know are perpendicular because I did opposite reciprocal slopes. So this would be 3, -4 would be the coordinates, which is also the component form. So u would be the component for 3, v, so this is u, this is v, v would be in component form 3, -4. Now I'm going to do the dot product, so u dot v would be 4 times 3 plus 3 times -4, so that's 12 plus -12 equals 0. Okay, and that's actually true. So of any of them, so any picture you drew, if you had two perpendicular lines, their dot product is going to be 0. So if u dot v equals 0, then u and v are perpendicular. And another word for that, perpendicular basically just means they meet at a right angle, and you're really just talking about one plane. Orthogonal means any plane you're looking at. So basically, here's two perpendicular lines. If I put a third vector here like this, there's a vector coming straight out at you. It is perpendicular to both of those vectors. So it'd be orthogonal to them. So orthogonal means within any plane, any dimension you're talking about, they meet at a right angle. So they are orthogonal. Okay, so orthogonal is a fancy word for perpendicular. Now, we said on the front side that anytime you want to find the angle between two vectors, use this formula, which when I said solve for theta, theta equaled the inverse cosine, just copying from the front. So u dot v divided by the magnitude of u times the magnitude of v. So find the angle between u and v if u and v are this. So I'm going to do, so the inverse cosine of, and the dot product would be 2 times negative 2, so that's negative 4 plus 15. So that would be 11. And then the magnitude here, the magnitude, both going to be square rooted. It's going to be 2 squared plus 3 squared. So it'd be 4 plus 9, which is 13. And then this one would be 2 squared plus 5 squared. Notice I don't care about the negatives, I'm squaring it. So 4 plus 25 is 29. You could actually type in the calculator like that. You could write this, well, yeah, you could do the square root of 13 times 29 too when you put in the calculator for the denominator. So it might save a few buttons if you did it that way. But type in the calculator inverse cosine and then 11 divided by, and then square root of 13 times 29 all under the radical, and you get 55.5 degrees. Now we said if the dot product was 0, it's perpendicular. So if the dot product is 0, it means this is 0. 0 over anything is 0. If you do the inverse cosine of 0, so inverse cosine of 0, as I did it here, inverse cosine of 0 is 90. So that's another reason why. So that holds true in this too. Find the angle between these two. So theta equals inverse cosine, dot product here. So 2 times negative 1 is negative 2. So negative 2 plus 3 would be 1. Then on bottom, their magnitudes being multiplied together. And you could put one big radical, I guess, and put times between them. This would be 2 squared plus 1 squared, which is 5. 1 squared plus 3 squared, that'd be 1 plus 9 is 10. So you could do the inverse cosine of 1 over radical 50 if you want to type less things in the calculator, because that's what this equals. And you get 81.9 degrees for that. So pretty easy formula to use, as long as you got it, as long as you remember it and use it, know how to use it. At the bottom here, I'll actually just, if you notice, a lot of these are kind of the same. So I'm gonna do the odds here real fast. I mean, nothing spectacular about this, but it says here's U, here's V, here's W, and we're supposed to find the indicated quantity, and then we're supposed to say whether it's a vector or a scalar, because some of these will result in a new vector. Some of these will just be a scalar, a number. So if I look at number 9, U dot U, so that's with itself, so 2, and the other x component is 2, so that'd be 4. 2 times 2 is 4, plus, and then the y components would be 2 and 2, so that's 4. Add together, that's 8, so that's a dot product, and that's just a scalar. Number 11, it looks kind of weird. And you might think, well, what about those properties in the front? None of those properties say what to do with this. And what it is, this dot product is a scalar. And I'm going to take a scalar times a vector, which we did in day 1. So we already know how to do that. So I'm going to find the scalar first, the vector. I'm sorry, the dot product, and then multiply by the vector. So U dot V is these two guys, so it'd be 2 times 3 is negative 6 plus, and then 2 times 4 is 8. So that's going to be a scalar that I'm going to multiply by the vector V, which is negative 3, 4. So this is 2. So it means I'm going to double both of these. So 2, the scalar, times this vector would be negative 6, comma 8, and that is a whole new vector. So this answer is a vector. Number 3, sort of the same idea here. We're going to take 3 times W. So 3 times W, I'll just write that down first. So 3 times W, that'd be 3, negative 6. So it's a dot product that with V, which is negative 3, 4. And when I get that answer, that's a scalar that I'm going to multiply by U, which is 2, comma 2. So dot product with these would be negative 9 plus negative 24, which is negative 33. So it'd be negative 33 scalar times the vector 2, comma 2, which is going to be negative 66, comma negative 66. Again, that answer is a vector. 15, the magnitude of W minus 1. The magnitude of W is going to be the square root of 1 squared plus 2 squared. So that'd be square root of 5, and then minus 1. And notice there's no vectors here, there's no components. These are just numbers, so I'm going to leave that like that. So square root of 5 minus 1, that's a scalar. You can type in the calculator from the decimal form. And the last one, dot product, and then subtract them. So I'm going to have a dot product, which is a scalar, minus another scalar, so my answer is going to be a scalar. So u dot v, so this would be, negative 6 plus 4. So negative 6 plus 4 is 2, minus, and then u dot w. So these guys here, that'd be 2 plus negative 4. So 2 plus negative 4 is negative 2. And then subtract minus the negative would be a plus, so that equal 4, which is a scalar. Okay. So like I said, these are pretty much the same thing, so I'm just going to do the odds on that one just so you can see how some of those work.